Hi, my name is Sydney, and this summer I worked for Werkr Tractors, an engineering company based in Waterloo, Ontario, that designs electric tractors. Werkr Tractors is a startup whose goal is to develop electric tractors with provision for autonomy. Our tractor is designed for small to medium-sized farms, where an electric tractor is powerful enough and can be built inexpensively using components that are already being manufactured. We are currently working on an autonomous mode, where farmers can map a path and the tractor will be able to follow it with the precision of 1 inch. Fertile Ground is an organic market garden that grows vegetables for a local 200-share CSA. They farm on 5 acres and have chickens, a greenhouse, as well as 2 farm-mill tractors from the 1960s. These tractors, which often do not start, were the inspiration for our electric tractor, which aims to fit the niche job that these old farm-mills currently fill. I spent my summer working in the machine shop as well as on the farm. In the shop, I worked on the lathe, the milling machine, the CNC machine, and welded. On the farm, there were seedlings to transplant, seeding to be done, crops to weed, row cover and irrigation to set up, and vegetables to harvest. I began my internship by making weeding implements to be used to test the tractor's power and agility while working in the field. I worked on the milling machine and the lathe mainly to make the various parts, and then welded the parts together to form a basket weeder and a finger weeder. Basket weeders are used to weed in between the rows and can be used when the crop is small. The first row of rods spins slower as it is dragged across the ground to guide the implement, while the second row spins faster to displace the dirt and weeds. Finger weeders weed between each plant in a row, and are used when the plants are a bit bigger and are securely rooted into the ground. The yellow rubber fingers uproot small weeds and cover the larger weeds with soil, effectively killing them. Another project I worked on this summer was performing trials with the tractor. This included seeding 3 beds with different crops, radishes, spinach, and onions. Then we used the tractor and implements to weed the plants. From this, we were able to test the tractor and its battery life, transportation logistics, and the weeding implements. In addition, I spent my time creating a wiring harness for the tractor, designing a waterproof casing for the GPS base station, fixing and improving aspects of the first prototype, and preparing parts for the second. My work this summer gave me an insight into the entire engineering design process, from designing each individual part on SolidWorks to making these parts from drawings in the shop, and then welding parts together and painting them to achieve the frame, and then adding the electrical components such as the battery, controllers, sensors, and motors. Even after the prototype worked, it still needed to be tested and marketed. In addition, I realized the importance of learning from the client when you are designing a product. Working on the farm helped me understand practical ways to make the tractor more efficient and user-friendly. On a more technical note, I learned in more detail how a brushless DC motor works while putting them together and balancing them. I gained a more in-depth understanding of electric circuits and the components of an electric vehicle, like the battery, VCM, and contactor. Machining tractor parts forced me to consider the material properties and high stress points when choosing how and what material to use in the tractor design. I think this project touches on so many important issues that we are facing today. Electrification reduces the use of fossil fuels. Autonomy is allowing farmers to minimize the use of spray, dealing with labor shortages, reducing farmers' workload, and it could make it possible for electric tractors to be more widely used. Considering the next step for this project, the integration of AI in agriculture for tasks such as row detection or weed detection represents the future of farming. This technology will be crucial in addressing the challenges of feeding a growing world population.